So this is one of the solution videos for the midterm for my physical computing course. Now this course has no prerequisites, so for many students this is their first programming course. Our first midterm was a 2.5-hour exam where students used all of their hardware: Circuit Playground Bluefruits, NeoPixel light strips with alligator clips, potentiometers, servos, and additional alligator clips, plus their laptops to complete 9 builds using CircuitPython. Now they could reference any of the prior code that they had built as part of the CircuitPython school videos or in-class exercises, but that was it. No additional notes, no use of the internet. It's always tough to figure out where to draw the line in terms of what additional resources students could use, but I figured this was a good balance to make sure that students had a decent recall level understanding of concepts, and they were able to perform in code interviews, but they could still reference prior work for their knowledge nudge since these concepts were still very new to many. Now, this course's exam is less demanding than my iOS course, since with physical computing we often assemble code that we've already written to build new projects, whereas the other class really expects students to develop some serious software engineering skills. So in this video, we're going to cover the first 3 questions which lead up to building the Wingwoman Wingman alarm, and we'll show these questions and their solutions. You'll probably notice questions get more difficult the further on we get toward the 9th question. So the first question challenged students to pulse the CPB in red, so start out in dark, and then all the lights should increase in brightness 1 increment at a time until 100% brightness is achieved. They should move forward at 1/100th of a second, pausing between increments. Then they should move back down to 0 brightness, also in 100 increments with 0.01 seconds between them. Now the code to do this should be written in a function called red_pulse, and that should be called from the while true loop, and when done it should look like this. And here's how to solve the problem. So in this code, we're going to be using the board, the NeoPixel, and the time libraries. Then in the next 3 line, we set up the onboard NeoPixels on the CPB. So we access them from board.NeoPixel. We have 10 lights on the NeoPixel. This is how we set up a NeoPixel object. We call that pixels. We set up the color red. Then in while true, we continually call pulse red. And this is our pulse red function. So we define the function. We're passing in no values. We initially set the brightness to 0. Then we set the pixels so that they fill in red, and then we go through a range from 0 to 100. Remember, we're going to go up to 101, but we never reach it. We're 0 indexed, so we want to go from 0 to 100, and then we set pixels brightness to 1 divided by 100, because remember, the brightness is a value from 0.0 to 1.0. We sleep for 1/100th of a second, and by the time we get down here, we should be fully bright. Remember, we go from 0 to 100, so we've set that all the way up to 100. Then when we're through and everything is fully bright, we go from 100 down to 0. Remember, we go down 2, but we never reach -1, and we go down by an increment of -1. So we just go in the other direction. It's the opposite of this loop here, but the code inside is exactly the same. We could have called pixels fill red outside of this function, but we're going to need to put it back in the function when we get to our later question, so I kept it in here. Now in the next question, we sparkle lights randomly when button A is pressed. The light should be white. We first turn on a single random light out of the 10 available. We wait 1/10 of a second, and then we turn the light off, and then we restart over again. Now we're just turning on the animation. There's no need to turn the animation off in this question. The function that we use should be called sparkle, and I also ask that you show that you know how to pass a value into a function and return that value. So the value that passed in the function should be called last_random, which is the last light sparkled. We should also return a value and then assign that to last random, so we keep track of the last light that was sparkled, and when we're done, the code should execute like this. And the code runs continuously. This is just a short video clip. So we import the same libraries that we did before, but we also need to add random and digital I/O. Digital I/O because we're working with buttons. And then the next 2 lines here set up button A, so we declare a digital in/out for button A. Then we set up switch to input. Remember, we need to set up a pull down resistor when we work with the buttons that are built into the Circuit Playground Bluefruit. We once again set up the pixels that are built into the CPB. We declare the colors white and black. Initially, we're going to set our random to -1. That's because we haven't generated any number. And since -1 isn't in the range 0 to 9, that will make sure that I consider all numbers 0 to 9 when I show you how we use the while loop for non-repeating randoms inside of the sparkle function. The sparkle on value is going to keep track of whether or not the animation is running. Initially, the animation is not running because we haven't pressed the button yet, so the sparkle on Boolean value is set to false. Then down in our while true loop, we check to see if sparkle on is true. If it is true, then we call sparkle to sparkle the CPB, we pass in random, and the value that we return, we set to last random. But if button A is pressed, that's what the dot value does. When it's true, we know it's pressed. We set sparkle onto true, and we call sparkle for the first time. Again, passing in last random and setting the return value to last random. Now, if sparkle on remains false and no button has been pressed, we're not doing any sparkling at all. Inside the sparkle function, what we do is we generate a random number using random.randint from 0 to 9. This is going to do all of those numbers inclusive, so we could get any number as low as 0 and including 9. Now, what we do here as well to make sure that we don't have a repeated random number, which wasn't necessarily asked for in the question, is we check to see if the last random number equals the random number, and if it does, we generate a random number again. So we will continue to generate a random number inside of this while clause until we get a number which is different from the last random number. So once we get a new random number, then we set that pixel to white, we wait for 1/10 of a second, then we set the pixel to black to turn it off, we set that current random number, the pixel that we lit up, to the last random number, and we pass the last random number back. So hopefully you got that. Feel free to look at this closely. I didn't require you to make sure that the numbers did not repeat, but you should know how to do that for future exams. This is something that we did learn, so I want to make sure that you know how to use while loops in addition to for loops. And now let's put all this together in our Wingwoman Wingman alarm. So this built us up to question 3, and the idea behind this is you'll code a CPB so that it is a wearable. Now, we actually built this wearable in another class that I taught. If you 3D printed a case for the CPB and used a LiPo battery, you could hang this around your neck as a necklace. It's really not very heavy. And in the video I show you, you can even put something over the top to diffuse the light like a seashell. And if you wear this at a party, when everything is okay, you could have it sparkling nicely. But if you need to be bailed out, maybe there's a creeper who you just can't shake, or you need a break from an awkward conversation, you can press button B and the necklace will start to pulse in red. And if your buds see this, then that will signal them that they should swoop in and rescue you. Very useful. Here's how it works. Things start out dark. Press button A and the sparkle function runs, and the CPB will start to sparkle. Press button B and the CPB pulses in red with the pulse red function that you wrote, and if you press A again, you'll toggle back to sparkle, B again toggles back to pulse red. And here's how we build it. So here's our code for this. We import the same libraries. We already set up button A, but we need to set up a button B for this as well. We set up our NeoPixel, make sure that you have all of your colors set up. Now we have values down here to keep track of our last random value for sparkling. We haven't sparkled any yet, so I initially set this to -1. Animate is going to be a Boolean value that we use down in our while true to tell if we are animating or not, essentially telling whether one of the buttons has been pressed or not. Sparkle animation tells if we should be performing the sparkle animation. Now there are lots of ways to implement this in the while true loop. The way that I've demonstrated here is using a nested if statement. So first we check to see if we are animating any of the lights. If we are, then we're either animating with a sparkle animation or we're pulsing in red. So if sparkle animation is true, then we call sparkle, otherwise we pulse red. And if we're not animating, then we want to make sure that we set the pixels to black so that we don't have any animations happening. Now if button A is pressed, what we do is we set animation to true, so we make sure when we go through the while true loop that we are animating, and we set sparkle animation to true. We also set the pixel brightness. This is something that stumped some students. You want to make sure that you do this because when you went through and set up your pulse red, you ended at a pixel brightness of 0. You went from 100 down to 0. And so I noticed that a couple of students had forgotten to set their pixel brightness so that some of the sparkle animation would show. The sparkle animation was accurately running, but if you haven't set your pixel brightness back up to a value that you can see, you're just sparkling with the brightness at 0 and you can't see anything. So that problem would occur if you pressed A, then B, then A again. Another thing some students forgot to do was to set all pixels to black, and that can be important to make sure that you don't have any lights that are currently set up in red. So even though you pulse through in red, if you go all the way down to brightness level 0, you still have all of those red lights since you did a pixel fill in red that are in red. So if you want to go ahead and start sparkling, you've got to turn off all of the red lights first before you call sparkle. Otherwise, you're going to see some red lights in that first sparkle. Now, if you press button B, you still want to say animate to true, but you want to make sure that you set sparkle animation to false. There's no reason to reset any of the lights up here because pulse red is going to start at 0 and immediately set everything to red in the way that we've written our code up here. So hopefully that's clear to you too. You can go through and see how things were set up, and feel free to see me or a TA if you have any questions in terms of how this runs. So hopefully these first 3 questions worked out for you. The videos that follow will cover the remaining 6 questions. And a quick note to educators. So I deliberately make my midterms low stakes, just 10% of their final grade, and I provide them with a way to make up some additional points with a retake with no notes if the student completely bombed the first test. And that would be at a maximum of 70 points on the retake. And I call this policy no coder left behind, because my goal as an instructor isn't to weed out students. Instead, it's to make sure that everyone leaves the course with a base skill level. And since the first coding test can be challenging for many new students, I want to make sure that it doesn't discourage students from pursuing technology, but instead encourages students to keep at it, double down, come back, improve, and hopefully do well on subsequent tests. So hopefully that piece of advice is useful for other educators out there, and I'll see everyone in the next video.